Project 5 was to connect two ESP32 to one phone. One ESP32 would have our reaction and motion time test. For this ESP32, we would test reaction time by flashing an image on screen and have the user tap the image as fast as possible. Their reaction time would be displayed on screen. Motion time is calculated by how long it takes the user to let go of the button to tap the image on screen. The image appears randomly on screen each test. We have a button that connects us to ESP32 via Bluetooth and the other starts a new test. Our second ESP32 would ideally take EMG sensor readings by connecting the EMG sensor to the user's bicep. When they took the reaction time and motion time test, their muscle movements would be recorded on the chart on screen. Since we don't have an EMG sensor, our Arduino code makes mock EMG readings, and these readings are sent via Bluetooth to our phone. We didn't want the graph to run continuously, so we only run a few points at a time, but the user can get a new graph by tapping the Generate Graph button. We added a fun theme to our app.
These are going to be our Arduino codes. The first code will be for our first ESP32, which is for the reaction time test. We include the BLE libraries, and we make sure that there's nothing connected. For the push button, we're using button 25. We set it as high at the beginning, so that means that the button is not pressed. This is our service UUID. Now our characteristic 1 UUID. These have to match to the MIT app so it can connect successfully. Here we handle the callbacks and make sure that the client is connected. In the setup, we begin the serial monitor, even though we're not using it for this project. We set the push button as an input pull-up so we could read the button state. And this is the name of our device. And this is the name that's going to appear when we try to connect it to our phone. Here we just start advertising the device. In the loop, we read the current state button of the push button. If it's pressed, we send the information to the phone. If it's not pressed, we also send that to the phone, and then we update it. And then here we include a small delay. This code is for our second ESP32, which is for the EMG test. Since we can't get an actual EMG sensor, this code makes fake EMG waves, and these are sent to the app to generate our chart. These are service UIDs and then characteristic. These also have to match the MIT app to connect. This is to send a value to the MIT app so it can initialize a list. In the loop, we begin serial monitor. We have the serial monitor also display how the EMG signals will look. This information is being sent to the MIT app, and from this we are generating a chart. Since it's continuous in the MIT app, we only get a small points at a time, and the user can generate a new graph whenever they press the button. This is the name of this ESP32. It's the name that's going to appear when we try to connect. And then this property is to notify. Right here in the loop, we generate the fake EMG, the baseline, and then the burst is random. And then the EMG value will be the baseline plus the burst. And then this is the data being sent to the ESP32. Well, this is the data being sent to the MIT app. And then we include a small delay. This is our MIT app code. This is how the screen looks on the MIT app. And this is how the app looks once we connect it to a phone. And this is our block code. Here we have some global variables. These right here are for our reaction time test. So for our ESP32. Here we initialize the screen. We have some music on looping in the background. We connect the first BLE device. And here we're still connecting to the first ESP32. And for this ESP32, we are receiving bytes. This is to start our reaction time test. This part here moves the image randomly on the screen. And this is to connect the second ESP32. We want to register for strings. And this right here will make our graph using the bytes we get from the string. And this last part is just to generate a new graph.